So, you want to land a job in artificial intelligence. It can feel like you're trying to crack a really tough code. But what if you had an insider's guide? Well, that's what this is. We're going to break down exactly what you need to know to walk in and absolutely ace your AI interview. Look, I've been on the other side of the table. I've interviewed hundreds of candidates, and I've seen what works and what really doesn't. I've seen brilliant people stumble over the same things. So today, I'm going to pull back the curtain and show you everything, from the basic concepts to the deep technical questions, so you can walk into that room feeling prepared and totally confident. So why is everyone talking about AI right now? Well, because the opportunity is just huge. The Bureau of Labor Statistics is predicting a 26% explosion in AI and machine learning jobs by 2032. That's not just growth, that's a boom. Seriously, the demand for people with these skills is red hot. And you guessed it, with that kind of demand comes some pretty incredible earning potential. In the US, an AI engineer is looking at an average salary of over $166,000. And the top folks, they're clearing $172K. So this isn't just an interesting job, it's a seriously lucrative career path. Okay, so here's our roadmap. We're going to start with the job market, get the lay of the land. Then we'll dive into the fundamentals you absolutely have to know. From there, we'll connect the dots to how AI actually works in business, then get into the tough technical stuff, and finally, we'll wrap it all up with your interview game plan. All right, first step, let's talk about the big picture, the AI job market. You've got to understand the playing field before you can figure out how to win. I mean, the numbers here really do speak for themselves. We're talking over 13,000 AI jobs open in the US right now, and more than 54,000 across the globe. And the roles are all over the map, from machine learning engineer and data scientist to research scientist. The demand is everywhere. Okay, let's get to the foundation. In pretty much any AI interview, they're going to test you on the basics. Getting these concepts right shows you've actually done your homework and you're not just throwing buzzwords around. First up, the big one, artificial intelligence, or AI. The best way to think about AI is as this giant umbrella term. It's the whole field of computer science that's trying to make machines do things that normally require human intelligence, like learning, reasoning, and solving problems. Now, living under that big AI umbrella is machine learning, ML, and this is super important. It's not a different thing from AI. It's a way of doing AI. It's a subset. Machine learning is all about building computer programs that can learn and improve from data all by themselves without a human having to code every single rule. And if we go one level deeper, we find deep learning. This is a specific type of machine learning that uses these really complex structures called artificial neural networks, which, are kind of modeled after the neural networks in our own brains. This is the tech behind some of the most advanced and accurate AI out there today. Okay, get ready for this one because it's a classic interview question. What's the difference between weak and strong AI? So weak AI, sometimes called narrow AI, is basically all the AI we have today. Think Siri, think Alexa. It's incredibly good at one specific task. Strong AI, well, that's the stuff of science fiction for now. It's the holy grail, a machine with real, human-like intelligence and consciousness. We are not there yet. Every builder needs their tools, right? Well, in the world of AI, Python is, without a doubt, the king. That's because of amazing libraries like TensorFlow and PyTorch. R is still super important for heavy-duty statistics, and it's also smart to know about the older languages like Lisp and Prolog. It shows you appreciate the history of the field. Okay, so you've got the theory down. That's great. But here's the thing interviewers really want to see. Can you connect that theory to actual business value? Let's talk about how this stuff is actually used in the real world. So this table breaks down the 3 big learning models. And here's an easy way to think about it. Supervised learning is like you're teaching a kid with flashcards that have the answers on the back. Unsupervised learning is like giving that kid a huge pile of Legos and saying, sort these into groups that make sense. And reinforcement learning, that's like teaching a dog a new trick by giving it a treat every time it gets it right. Think about Netflix or Amazon for a second. That's a perfect example of machine learning in the wild. Their recommendation systems use techniques like collaborative filtering, which basically says, hey, people who liked this movie also liked that one, to figure out exactly what you want to watch or buy next. And then you have the big one, right? Self-driving cars. This is AI at a massive scale. The systems in these cars are crunching a constant stream of sensor data just to navigate down the street. And the goal is enormous, trying to eliminate the over 90% of car accidents caused by human error.
The truth is, AI is already woven into our daily lives, sometimes in ways you don't even notice.
It's helping grade essays. It's what's behind Google Maps finding you the fastest way home. It's protecting your bank account from fraud, and it's powering those chatbots you talk to online. Knowing these applications is crucial. All right, deep breath. It's time for the technical gauntlet. This is where the interviewer really separates the people who just know the buzzwords from the ones who can actually build things. This is where you prove you can do the work. I can almost guarantee you're going to get a question just like this. It's a fundamental test of how well you understand algorithms. So let's break down the answer visually. So what's the big difference here? It all comes down to how they explore. Breadth First Search, or BFS, goes wide. It checks all the neighbors on one level before it goes any deeper. Depth First Search, DFS, goes deep. It follows one single path all the way to the end before it ever backtracks. The trade-off? BFS uses more memory, but it will find the shortest path. DFS is lighter on memory, but it might go way down a long, wrong path before it finds the answer. And while we're on the topic, another huge one you need to know is A-star search. This thing is an absolute powerhouse for path-finding problems, like in video games or Google Maps. It's famous for being super efficient at finding the best possible route from point A to point B. Okay, last section. Let's talk about your game plan, because it's not just about what you know, it's about how you communicate what you know. This is how you bring it all together. So when the interviewer leans in and says, "So, how would you solve this problem?" This is your time to shine. Don't just blurt out the name of an algorithm. Walk them through your thinking. Start by categorizing the problem. Ask questions about the constraints. Do we need speed, accuracy? Then you can suggest a couple of possible algorithms and explain the trade-offs. This shows you're a strategic thinker, not just someone who memorized a list. So there you have it. We've gone through the market, the core concepts, the real-world applications, and the interview strategy. The demand for people who can do this work is off the charts, and what they're building is literally changing the world. The only question left is, are you ready to be a part of it?